Algebra 2 students, in this video we will be studying characteristics of matrices. Now, of course, the word matrices is plural for the word matrix, okay? We are also going to learn how to add and subtract matrices. Your heading for today is Adding and Subtracting Matrices, Lesson 4.1. And be sure and include today's date like you always should so that your notes are organized, okay? So, adding and subtracting matrices, lesson 4.1, and be sure and include today's date. Now, like usual, let's start off with a definition of what a matrix is. You are not responsible for this matrix, but I still want you to copy it in your notes, okay? So please copy this definition in your notes. Matrix, a rectangular array or order of numbers in rows and columns, enclosed in brackets. Please copy that down. A rectangular array or a rectangular order of numbers in rows and columns, enclosed in brackets. Now, like I tell you guys all the time, if I go too fast in the video, pause it. Okay, that's what it's there for. Here's an example of a matrix. Please copy this down. Bracket here, 1, 2, 3, -4, 5, and 0. Okay? So inside of a matrix, you can have positive numbers, you can have negative numbers, you can have a 0. They can come in all kinds of arrangements. A matrix could look like this. There we go. It could look really kind of weird like this, really. A matrix could look like this. You could just have one long row of numbers. Okay, so this is what a matrix looks like, and I'm sure you've seen some of these in Algebra 1 before, but a matrix is a rectangular array of numbers in rows and columns, enclosed in brackets. You might say, well, Mr. Earhart, I see a row here but no columns. Yeah, you have one row of numbers, but this is a column, this is a column, this is a column, this is a column. You get the point. We always have rows and columns, okay? So there we go. Alright, moving on. Now, before we get or start adding and subtracting matrices, we have a lot of information to cover in this video. You are responsible for all of this information, so please take really good notes, okay? First of all, every matrix has an order. That should be an. Every matrix has an order or dimension. Let me show you what I mean, okay? The words order and dimension can be used interchangeably when dealing with matrices, okay? Excuse me. So if I ask you on a test or quiz to find the order of a matrix or to find the dimension of a matrix, it's the exact same thing, okay? Now, here's an example of a matrix. Please copy this down. There we go. Now, I want to talk to you about the order of this matrix or the dimension of this matrix. Are you ready? Please pay close attention. Whenever I ask you to find the order or the dimension of a matrix, you put the rows first and the columns second. You also put a little X here, but that X does not mean multiply, it means the word by. So when you see that X, it means rows by columns, okay? So, here's how I've taught my students in the past to remember this. Think of RC Coca-Cola, RC. That's back in the old days, but still you've heard of RC Cola, Coca-Cola, RC Cola. So remember, R comes first, C comes second. And there's other ways you can remember that if you want to. Think of your own way. But remember the R comes first. So let's count the rows. By the way, Mr. Earhart, what's rows? What's columns? Remember back in the old days, Here's the front porch of a house, and the roof was up. The roof was up here, and there were columns going up on the front porch of a house. Remember those old houses that have columns going up like this? Well, columns run left to right or up and down. They run up and down, okay? So that's how you can remember columns run up and down. Rows run left to right. So count the rows. Are you ready? 1, 2. How many rows did I have? 2. Now count the columns. 1, 2, 3. How many columns did I have? 3. So we call this a 2 by 3. If you call this a 3 by 2, you would miss it. That is wrong. The rows must come first. The columns must come second. This is a 2 by 3 matrix. Got it? Try another example. How about this one? Copy this in your notes. What if I had a really long matrix like this? Okay. What if I asked you for the order or the dimension of this matrix? Well, your rows come first. Count the rows. 1, 2, 3, 4. So I have 4 rows. How many columns do I have going up and down? 1. So this is called a 4 by 1 matrix. Do you see how to do this? It's very important you understand how to find the order or the dimension of a matrix. When we start multiplying matrices, this will be very, very important. Also, when we go to enter these into your calculators, they're going to ask you what dimension, sorry for yawning, I apologize, what dimension your matrix is. You have to know how to do that, okay? So let's take a look at one more matrix. What does it say? 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? Well, your rows come first. Count the rows. 1, 2, 3. Your columns come second. Count the columns. 1, 2, 3. So in this case, your rows matched your columns. We call this a 3 by 3 matrix. A 3 by 3. I'm going to move on, students. I hope you're grasping this. The main thing to remember is rows comes first when you write your dimensions. Columns come second. The next thing to remember is rows run left to right. Columns run north to south or up and down. Okay? Alright, moving on. The numbers in a matrix are called entries or elements. Now I want you to get used to both of these words here. But the textbook we're using uses the word order, I believe, but either one is fine. I want you to be used to both of these words. I believe the textbook we're using uses the word entries, but be used to both of these words. So, if I gave you a matrix like this, you could write this down or just watch. It's up to you. If I gave you a matrix like that, first of all, the dimensions would be a 2 by 3, 2 rows, 3 columns. But secondly, if I said, how many entries or how many elements do you have? You'd say 1, 2, 3, 4, 5, 6. There are 6 entries or 6 elements in this matrix. Do you understand? So all of these numbers inside of a matrix are called entries or elements. Now there are different kinds of matrices. Excuse me, please. I'm going to go over them now. You are not responsible for these definitions, but you do need to understand what I am talking about when I use these terms, okay? And there are some other types of matrices. Identity matrix, inverse matrix. We're going to talk about those later on in chapter 4, okay? But for this lesson, here are the ones I want you to be familiar with. Here we go. A row matrix is a matrix that has one row. You can listen or take notes, up to you. That's a row matrix. This would be a row matrix. Even this would be a row matrix. That's a 1 by 1. That's 1 row and 1 column. That's a 1 by 1. Okay? All of these are row matrices because they have one row. Doesn't matter how many columns. This one has 4 columns. This one has 2 columns. This one has 1 column. Doesn't matter. A row matrix is a matrix that has exactly 1 row. Okay? Having said that, then once I give you this next term, I'm sure you can figure out a column matrix. Well, a column matrix has only 1 column. It can be really long, doesn't matter. You can copy these down or just watch. If you think you'll remember this, that's fine. It's up to you. This would be a column matrix. That's also a row matrix. It has 1 row, 1 column, a 1 by 1. This is a column matrix. This is also a row matrix. This is a column matrix. This is a this is a column matrix. A column matrix is any matrix that has 1 column. Okay? Alright, a column matrix is a matrix that has 1 column. A square matrix, now listen to me carefully, it's any matrix that has the same amount of rows as columns. This is a square matrix because it's a 1 by 1. This is a square matrix because that is a 2 by 2. 2 rows, 2 columns. 1 row, 1 column. This is a square matrix. That is a square matrix because I have 3 rows and 3 columns. It's a 3 by 3. So whenever your rows match the columns, in other words, there's the same amount of rows as there are columns, then you have a square matrix. I could go on. I could draw a 4 by 4, a 5 by 5, a 6 by 6. There's no need to do that. You understand a square matrix is a matrix that has the same amount of rows as columns, or the same amount of columns as rows, okay? So a row matrix is a matrix with 1 row. A column matrix is a matrix with 1 column. A square matrix is a matrix in which the columns and the rows are the same. They have the same amount of columns as rows. Now a zero matrix, okay? Let's talk about this for a second. A zero matrix is a matrix whose entries or elements are all zeros. Okay? So this would be a 0 matrix. This would be a 0 matrix. This would be a 0 matrix. I mean, it doesn't matter, guys. It doesn't matter how many rows. It doesn't matter how many columns. A 0 matrix is a matrix in which every single entry and element is 0. Okay? That's pretty simple. Row matrix has 1 row. Column matrix has 1 column. Square matrix has the same amount of rows as columns. 0 matrix, all of the entries or elements would be 0. Now let's take a look at adding and subtracting matrices. This is pretty easy stuff. Let's jump into this. Here's the first thing that you need to know, okay? Write this down, please. Matrices must have the same order/dimension in order to be added or subtracted. If one matrix is a 2 by 3, if you're going to add a matrix to that, it better be a 2 by 3. If it's not, if you have a 2 by 4, you cannot add those 2 matrices, or you cannot subtract them either. The dimensions or the order, whatever you want to call them, must be exactly the same in order for you to add or subtract 2 matrices. Please copy this in your notes and understand what I'm saying. Matrices must have the same order in order to be added or subtracted. If 2 matrices do not have the same order or dimension, then they cannot be added or subtracted. Their answer would simply be no solution, or cannot be added, cannot be subtracted, cannot be combined, whatever you want to put, but they numbers, okay? This is also a 3 by 2, so it's always important to check your dimensions. So I know my answer is also going to be a what? A 3 by 2. And here we go. Watch how easy this is. You take this entry here times this entry here. So 5 plus negative 2 is 3. If you're bad with sign numbers, use your calculator. Okay, please. Alright, then we take negative 3 plus 1, which is negative 2. Just check off each number as you use it. Negative 3 plus 3, check off this number. That would be 0. 4 plus 0. 4. 0 plus 4. 4. Check off this number. 7 plus negative 3. 4. Check off this number. Look at that. Now students, listen to me. That is really, really easy to do. Okay? If the dimensions or the orders are identical, then you go ahead and you add or subtract the two matrices. Really simple. Alright, next problem. Now, on this one, be careful. There's two ways to actually do this. I'm going to show you both ways, and you may choose whichever one you feel is easy for you to do, okay? I'm going to start off first with the way I like to do it, and please feel free to do it another way if you prefer another way. Here we go. Now, for me, now I'm probably going pretty fast. I know I pulled this problem up and started working. You probably had to pause the video and copy it down. That's fine. So if you got to pause the video and copy this down, that's fine. I'm going to move on, okay? Now, for me, I don't like to subtract. I would rather add like this than subtract, and most students are like that. Well, whenever you're subtracting two matrices, first run your test. You have a 2 by 2 and a 2 by 2, so we're good. We can add these together. Now, I don't like to subtract when I can add, so you're allowed to change this minus sign to a plus sign as long as you go to the matrix here to the right of the negative sign and change all of the signs in here. Let me say that again. If you have a negative sign here, you are more than welcome to change it to a positive as long as you change all the signs in here. Okay? So I'm going to make this negative become positive. This will become negative. This will become positive. This will become positive. This will become negative. There. Now I can add the two matrices. 8 plus negative 2. 3 plus 7. Negative 4 plus 6. Negative 4 plus negative 1. Look at that. There we go. Now that's how I like to do it. Some students like to keep the negative sign here. I have no problem with that. Just be very careful with your signs. They go like this. 8 minus 2. Now be careful here. 3 minus a negative 7. 3 minus a negative 7 is 3 plus 7. Okay? 3 minus a negative 7 is 3 plus 7, which gives you 10. Negative 4 minus a positive 6. Negative 4 minus a negative 6. Now you have two negatives here. That's the same thing as negative 4. Positive 6. Alright? So negative 4 positive 6 is going to give you a positive 2. And then negative 4 minus 1 will give you a negative 5. Now, either way is acceptable, students. It really is, okay? I don't care if you choose to first add. Okay, I'm back at a pause video. I don't care if you first choose to change the negative to an addition, then add, or if you leave it negative and then, go that direction. Just watch your signs, whichever way you do it. Notice you get the same answer either way. Okay, students? Alright, moving on. Here we go. Okay, now, I know I did not include this in your heading. I did not make a mistake. I just didn't feel like putting in your heading, adding, subtracting, and dealing with scalars. This number right here is called a scalar. It's just a fancy way for saying a number you're going to multiply through the matrix. It is just as easy as the ones that we just did. If you have a number outside of a matrix like we do right here, 4, you simply take that 4 and you multiply. Well, I was trying to pull this out of the way. You simply take that 4 and you multiply it through the matrix, okay? So here we go. 4 times negative 2. 4 times 0. 4 times 4. 4 times negative 1. Now guys, I'm not going to belabor that point any longer. That's really simple math, okay? Alright, last problem. Now this is a little more complex. I know these parentheses are really dark. They're not meant to be that way. That's just how they turned out, but all that means is I have 2 matrices inside of a parentheses being added. And then once I do that, I have a negative 2 here. Now look, if you had negative 2 and then 5 plus 7, okay, watch this please. You could take negative 2 times what? 12. 5 plus 7 is 12. Then you get what? Negative 24. Or you could take this negative 2 and multiply it through. Negative 10, negative 14, negative 24. Either way, you get the same answer, okay? It's the same thing up here with matrices. You are more than welcome to add these 2 matrices together first and get out one matrix, and then bring down your negative 2 and multiply it through. Or if you want, you can take this negative 2 and multiply it through times every single entry in both matrices. Now for me, that's a lot more work. I do not recommend you do that, but you can. I am not going to work it out for you that way because it's pretty unorthodox. But just so you have an understanding of matrices, you could do that. What I'm going to do is bring down my negative 2. I'm going to put a matrix right here. And now I'm going to add these 2 matrices together and put my result right here. Okay? 1 plus negative 4. Negative 2 plus 5. 0 plus 6. 3 plus negative 8. There we go. Pretty simple, students. Okay, so I added my 2 matrices together. Next, I'm going to take the negative 2 and multiply it through, and I'm finished. Negative 2 times negative 3. Negative 2 times positive 3. Negative 2 times positive 6. Negative 2 times negative 5. Now I hope in these notes I've not made a little mistake somewhere. I hope I've, done this the right way. But that is it. You're finished. Pretty simple. So the opening lesson today in this chapter is pretty easy. Adding and subtracting matrices and learning a lot of definitions and characteristics. And then also multiplying scalars through matrices also.